Welcome to EDU World Space.
Okay, so section 8.2, problem 30. This is a problem asking to figure out the surface area obtained by rotating the parabola about y-axis. So let's first organize what information is given by the problem. So given, we are given that we have a parabola going through an origin. This is my x-axis, and this is my y-axis. And we are given the curve y equals ax. We don't know what a is, but it's going to look like something like this. It's a parabola going through the origin. Okay, I know it's going through the origin because I've plugged 0 in x. I get a times 0 equals y. So the curve goes through 0, 0, the origin. Okay, and by rotating this curve about y-axis like this, we're going to get a dish looking like this. So kind of like that, right? Let's say this is the middle point. So if you look at it from the above, this is a perfect circle, and this is the bottom of it, right? This is the bottom of it, and the bottom touches the origin here, okay? And then it says the diameter is 10. So diameter, if you look at it, I have a circle, and the diameter here is 10, okay? And the max depth of this dish, it's kind of look like a bowl, but the depth of this dish, so from the top to the bottom, this length or depth of the dish is 2. Okay, so these numbers correspond to, on the graph, from here to here, if I draw a straight line, from this length of this red line is 10, and this curve is symmetric about y-axis. So if I drop a line from here straight down to the x-axis, I should get, this should be 5, because that corresponds to the radius of the circle, of the surface, of the circle, right? And the depth, max depth 2 corresponds to, let's change color. Here, this point should be y equals 2. Okay? So that's the given information. And the problem's asking us to find two things. So first, find the value of a here, y equals a squared. Find the value of a that describing this curve, and it's also asking us to find the surface area of the dish. Okay, so given this information, let's try to find a 1 and 2. Okay. So first, find a. Well, if you go back to the graph we just draw, this shows that this line goes through x equals 5 and y equals 2. This point here is 5, 2, right? So let's use that information to find out what the a is. So y equals ax squared goes through 0.52. Therefore, when y equals 2, I have x equals 5. That's what it means. And it's x squared, so it's 5 squared. And let's just solve for a. Then I have a equals 2 over 25. And we got the answer. So that's our answer. This is the value of a. Okay? So next. Oops. Next, part 2. Find surface area obtained by obtained by rotating. Well, we found out the curve is actually y equals 2 over 25x squared, right? Because we found what the a is. So rotating this curve, f of x equals 2 over 25x squared. Rotating this curve about y-axis. So that's what we want to figure out. Y-axis, all right? Now remember, the formula we learned in this section says surface area, big S, equals integral of 2 pi x times square root of 1 plus derivative of the curve, f of x, squared dx. Okay, this is the formula we learned in this section, right? Now we found out what the f of x is, so we can compute this integral, and we'll find out what the s is. Okay. All right. So continuing from the previous screen, surface area S equals integral of 2 pi x times square root of 1 plus f of x was 2 over 25x squared. This is our f of x, and we want to take a derivative of it, and then we're going to square it. Okay, dx. Also, we want to find out, to solve for x, we want to find out what the integration bound is. We need some numbers from here to here, right? Now, let's go back to the graph. We are going to integrate about x from 0 to 5 because that's the radius of the circle, okay? So the integration bound here should be, we are going to integrate this from 0 to 5, all right? So let's evaluate this integral, okay? 2 pi x square root of, okay, 1 plus, let's take a derivative of this first. So if I take a derivative of 2 over 25x squared, I get 4 over 25x. And we're going to square this. Dx, 0 to 5, 2 pi x times square root of 1 plus 4 over 25x squared, 625 in the bottom, 16 in the numerator, x squared dx. Okay. 0 to 5, 2 pi x. Then I can also rewrite this like this. I'm going to compute inside the square root. So I have 625 plus 16 x squared over 625 dx. Okay, let's go to that way. Okay, but the 625 was 25 squared. So, all right, 0 to 5. I have 2 pi x over 25. And then square root of 625 plus 16 x squared. Because this equals square root of numerator over square root of denominator, right? And the square root of denominator just becomes 25. So this whole thing, 2 pi over 25, this whole thing becomes just a constant. And I have, this is the numerator we have here, still in the radical sign, okay? Dx. Now, we need to use, this is a little complicated, but remember we need to use the substitution technique to solve this integral. So let's put this radicand as u. So now put u equals 625 plus 16x squared. Then I have du over dx equals 32x. I just took a derivative of this substitution. And then I have, by rearranging it, I get x dx equals du over 32. I just rearranged this, but just by like a regular algebra, okay? Then we can rewrite this integral with the substitution with u. So then s equals, I have, let's worry about the bounds later. For now, I want to rewrite this with u with, so 2 pi over 25. Now notice I have x here and dx here. So this is same as 2 pi over 25 times this radical x dx, right? So inside the radical becomes to be just u because that's what I set as u to be. U equals this radicand. And instead of x dx, I have x dx equals du over 32. So du over 32. 32. Okay, this looks much simpler, and this is what we're going to solve. But let's worry about this bound now. So when we have this equation in terms of x, I got 0 and 5. So when x equals 0, based on this substitution, I'll get, if I plug 0 into x, I get 625. So this here should be 625 because now this whole thing is in terms of u. Now x equals 5. When x equals 5, I get u equals, you just plug 5 into here, right? I get u equals 1025. So this is the new integral that we want to solve for. All right, we're almost there. So surface area is now integral from 625 to 1025 and 2 pi over 25 square root of u du over 32. Okay. Well, this is just du times 1 over 32 is sitting in front of du. So let's combine all the constant and take it outside the integral. Then I'll have 400 pi over 400. Why did I get 400? Because see, 2 cancel with 32 and I get 16. 16 times 25, I get 400. So pi over 400 and integral 265, 1025, square root of u du, right? Okay, then pi over 400 times 2 over 3 times u raised to 3 over 2. And we're going to evaluate this on 625 to 1025. Let's go that way. And we just plug in all these bounds in here, right? And then we subtract. So, let's we can clean up a little bit here. This is 200. So 200 times 3 is 600. So I get pi over 600. And I plug in 1025 into x raised to 3 over 2 minus 625 raised to 3 over 2. And if you compute this in a calculator, you should get something. I should use an approximation sign. Approximately something like 90.01193. And that's the value, that's the surface area of the dish, because this is S is approximately 90.01193 square feet. And that's the answer.